First, buckyball molecules created from boron. Chemists have made the famous soccer ball-shaped molecule using a new element that allowed an unexpected atomic arrangement. Just in time for the World Cup final, researchers have succeeded in building the first buckyballs made entirely from boron atoms. Unlike true carbon-based buckyballs, the boron molecules are not shaped exactly like soccer balls. But this novel form of boron might lead to new nanomaterials and could find uses in hydrogen storage. Robert Curl, Harold Kroto and Richard Smalley found the first buckyball, or Buckminster fullerene, in 1985. The hollow cage, made of 60 carbon atoms arranged in pentagons and hexagons like a soccer ball, got its name from the U.S. architect and engineer Richard Buckminster Fuller, who used the same shapes in designing his domes. The discovery opened the floodgates for creating more carbon structures with impressive qualities, such as carbon nanotubes and the single-atom thick graphene. Since then, material scientists have also searched for buckyball-like structures made of other elements. In 2007, Boris Jakobson, a material scientist at Rice University in Houston, Texas, theorized that a cage made of 80 boron atoms should be stable. Another study published just last week predicts a stable structure with 36 boron atoms. Publishing today in Nature Chemistry, a team led by Lai-Sheng Wang, a chemist at Brown University in Providence, Rhode Island, has become the first to see such a beast, although its structure is slightly different from that predicted. The researchers call their 40-atom molecule borosphyrine. It is arranged in hexagons, heptagons and triangles. We predicted the possibility of B80 fullerene, and now, 7 years after, it is remarkable to see experimental evidence, says Jakobson. Especially as it is not what any of the theoretical calculations predicted. Wang's team found the structure while looking for analogues of graphene made of boron. They found that clusters of 40 boron atoms seemed to be unusually stable, but they didn't know what form these clusters were taking. Further calculations and experiments revealed that they had made two stable structures, one an almost flat molecule, the other a hollow, ball-like structure made of tessellated shapes, similar to the carbon buckyball. In addition to having a less elegant shape, the borosphine balls form a different type of internal bond from their carbon counterparts. This makes them difficult to use as isolated building blocks as they have a tendency to interact with each other, but this reactivity may make boron buckyballs good for connecting in chains. It also makes the balls capable of bonding with hydrogen, which the team says could make them useful in hydrogen storage. Boron is not the first element after carbon to get buckyballed, but the result may be the closest analog to the carbon variety. Scientists have formed buckyball-like structures out of uranium-based and silicon-based compounds, mootly walled boron nitride and molybdenum disulfide structures and smaller single-element cages of gold, tin and lead. But only boron seems to match the large hollow cage and symmetry of the original carbon buckyball, says Jakobson.